NASA has released a new set of images capturing Comet 3I/Atlas, the third confirmed interstellar visitor ever to enter our solar system, marking a significant moment in modern astronomy. This release follows a period of silence caused by the recent U.S. government shutdown, during which public updates from NASA were temporarily halted. Despite the pause in communication, astronomers around the world continued observing the comet, using both space-based and ground-based instruments in an effort to better understand the mysterious object as it travels at extraordinary speed through our planetary neighborhood. Comet 3I/Atlas first came to scientific attention in July when it was detected by the Atlas Observatory in Chile, a NASA-supported system created to identify potentially dangerous asteroids and comets. The discovery immediately attracted global interest because interstellar objects passing through our solar system are extremely rare, with only two others, 1I/Oumuamua in 2017 and 2I/Borisov in 2019, ever having been confirmed in recorded history. Each of these objects gave scientists a brief but invaluable look into the building blocks of distant star systems, and 3I/Atlas offers another rare opportunity to study a traveler that originated far beyond the gravitational influence of the Sun. During the month-long government shutdown, NASA's outreach and public communication channels were paused, causing speculation, confusion, and a surge in online rumors. While the scientific community continued its work, ordinary citizens had no new official updates, which led to increased public curiosity about the comet's nature, trajectory, and possible risks. To fill the gap, other organizations, such as the European Space Agency, released their own observations. ESA published images captured during a Mars flyby using spacecraft not originally intended for tracking fast-moving interstellar objects, yet the orbiters proved capable of gathering meaningful data. These unexpected contributions from Mars-orbiting missions broadened the range of prospective scientists could use to analyze the comet's movement and behavior. When NASA resumed normal operations, its associate administrator Amit Kshatriya openly addressed the rumors circulating online, some of which speculated that the comet might be artificial or contain alien technology. Kshatriya dismissed such claims, reaffirming that the object is entirely natural, made of the same types of icy materials and dust that compose other known comets, though its interstellar origin makes it scientifically unique. Today, nearly a dozen spacecraft, observatories, and space telescopes are monitoring Comet 3I/Atlas from various vantage points throughout the solar system. NASA's latest image release includes data from the SOHO spacecraft, which focuses primarily on studying the Sun, but has also proven effective at tracking comets as they pass through the Sun's surrounding environment. Additional observations came from missions at Mars, including the Perseverance rover, the Mars Reconnaissance Orbiter, and MAVEN, each of which captured the comet under very different lighting conditions and viewing angles. These combined datasets form an unprecedented multi-platform observation campaign. Some of the most detailed images were recorded between October 15th and 16th by the collaborative ESA/NASA SOHO mission. These images revealed a subtle brightening of the comet as it drew closer to the Sun, a behavior that suggests increasing sublimation of its icy surface. As an interstellar visitor warms in sunlight, its frozen components vaporize, creating the glowing coma and tail that make comets visually spectacular. In the case of 3I/Atlas, this brightening is especially intriguing because scientists are eager to compare its chemical and physical responses to those observed in comets that formed within our own solar system. A major focus of the research surrounding 3I/Atlas involves understanding how it behaves before, during, and after perihelion, the moment when it reaches its closest distance to the Sun. For this comet, perihelion occurred on October 31st, when it came within approximately 126 million miles of the Sun. Although this distance is significant on a human scale, it is relatively close for an interstellar object that has been traveling through cold, dark interstellar space for potentially millions or even billions of years. Exposure to the heat and radiation of our star provides a unique opportunity to examine how its materials react, break apart, or release gases. Because the comet formed in a completely different star system, Its composition may include exotic molecular structures or unexpected ratios of familiar elements. Scientists hope that by measuring the gases released as the comet warms, such as carbon monoxide, carbon dioxide, methane, or more complex organic compounds, they can piece together clues about the environment in which the comet originally formed. The journey of 3I/Atlas through the solar system is a once-in-a-generation event, and astronomers are determined to gather as much data as possible before the object disappears back into interstellar space forever. According to NASA, the comet will make its closest approach to Earth on December 19th, though it will still remain a safe and very distant 170 million miles away. Even at such a distance, its brightness and the direction of its tail can be analyzed using sensitive telescopes around the world. The scientific community hopes that these observations will paint a clearer picture of how interstellar comets differ from those native to our solar system. Variations in structure, density, color, fragmentation patterns, or dust composition could potentially reveal the history of the comet's home star system, offering insights into how other solar systems formed and evolved. This information is crucial because studying interstellar material gives scientists a rare chance to compare the building blocks of planets and stars beyond our own cosmic neighborhood. As Comet 3I/Atlas continues its rapid passage, researchers emphasize that nearly everything about it provides valuable information. Its speed alone, which greatly exceeds typical solar system comet velocities, hints at a long and complex journey through regions of space shaped by gravitational forces from many different stars. The shape and orientation of its orbit also confirm that it originated outside the Sun's gravitational pull and is simply passing through. Instruments studying the comet look for patterns in how the tail develops, whether dust particles drift in smooth streams or break into uneven clusters, and whether the nucleus shows signs of fragmentation. Some interstellar visitors may contain volatile materials that react strongly to sunlight, while others may show unusual stability, surviving perihelion without major disintegration. The behavior of 3I/Atlas will help physicists refine their models and better predict how other interstellar objects might behave in the future. Another important scientific question involves comparing 3I/Atlas to the previous interstellar visitors. Oumuamua, discovered in 2017, caused intense debate because its shape, acceleration, and lack of a visible tail seemed unlike any comet previously observed, leading to theories ranging from exotic ice compositions to more speculative ideas. 2 years later, 2I/Borisov provided a clearer example of a comet that behaved more traditionally, yet still carried unique chemical signatures. Now 3I/Atlas offers a third opportunity, and with it, a chance to determine whether these rare visitors follow any consistent patterns or whether each represents a completely different type of interstellar body. If scientists can identify similarities among the three, it might indicate that certain types of material are common in many star systems. If the objects differ significantly, it could mean that comets form in dramatically varied environments across the galaxy. The renewed release of NASA's images has also generated significant public interest. People around the world are fascinated by the idea of an object that comes from another star system, carrying ancient material older than the Sun itself. The presence of such visitors reminds humanity of the vast, interconnected nature of our galaxy and the possibility that many more interstellar travelers pass through space unnoticed. Although most will remain too faint or too distant to detect, improved telescope technology and dedicated sky survey programs like Atlas increase the chances of identifying more of them in the coming decades. Every discovery expands our understanding of cosmic history and helps refine models of how matter moves between star systems over millions of years. As 3I/Atlas continues its journey, astronomers expect to gather data until it becomes too distant to observe. Once it leaves the inner solar system, it will drift back into the cold, dark expanse of interstellar space, possibly never again passing close enough to any star to warm its frozen surface. The data collected during its brief visit will become a lasting scientific resource, offering future researchers a detailed look at an object shaped by a completely different cosmic environment. The excitement surrounding this comet reflects both a scientific and human fascination with origins, travel, and the unknown. Each interstellar visitor carries with it a history from a distant region of the galaxy, and 3I/Atlas is the latest messenger from those faraway places, reminding us of how much remains to be discovered beyond the boundaries of our solar system.